It's Maths O'Clock with Mr. Hlajwayo. Welcome to another video. Greetings everyone. So what we are going to be looking at today, we are going to be examining our similarity theorem, right? So I think it is important that we firstly, get a little bit of understanding in terms of what does similarity theorem states. So let's start. Now, firstly, it states that if the corresponding angle in two triangles are equal, which means basically after you've constructed, if the two corresponding angles are equal, then the corresponding sides are then going to be in proportion, right? I know this statement won't necessarily make sense now, but as we dig deeper, we are going to understand in terms of what it actually implied. So now let's start. So firstly, what are we given here? We are given that triangle GHI, which is this bigger triangle, and triangle JKL, which is the smaller triangle. We are given that your angle G is equals to your angle J, which means this angle here is equals to this angle here. You are also given that your angle H, which is this angle here, is equals to your angle K. Similarly, you are given also that your angle I here, which is this one, is going to be equals to your angle L. So what we are required to prove, we are required to prove that your GH basically mean your GH over GK is equals to your GI over JK, over JL, and also is equals to HI over KL, or basically, which means all these sides are in proportion. So now let's start. So what is it that we are going to do firstly? So in order for us to be able to prove this, we are going to start by construction, right? So we are going to construct. You're going to construct M. So you're going to make label this side M on our GH. Which means on this, which means here we are going to have our point M. We are going to label it as M, and such that this side is equals to this side. Let's get so we are going to construct a M on GH such that our GM become or is equals to our JK, right? And then now what else we are going to do? We are going to then also construct and our N, so which means here we are going to have our side N here, such that our GN here, such that our GN is going to be equals to our JL, such that these two sides are equal, or this side is also equal to this side. Then we are going to obviously join our construction. We are going to join our construction, right? And then now, what is it that we are then going to look? Let's write join. We are joining our MN. And then after that, what is it that we are going to look? Now we are going to say, we are going to look at triangle. We are going to say in triangle G, M, N, and our triangle J, K, L. So in these two triangles, we are going to try and prove similarity between these two triangles, which is relatively going to be very much easy, because look, we are given that our angle G in this triangle is going to be equal to our angle J. This side is equal to this side. This was given to us in the beginning of our statement. What else are we given? We have constructed such a M such that your GM, remember we said your GM is equals to what? Your JK. So which means you're going to say your GM is equals to your JK. This is because of construction. Remember, after construction, we said these two must be equal. right? And also similarly, your GN was constructed such that it is equals to your JL. This is also because of construction. Now, can you see that you have proven three things to be equal? You have proven an angle plus two sides. So, therefore, you can actually conclude that triangle GMN is what is congruent to triangle what? To triangle JKL. And what is going to be a reason? Remember, we've proven two sides and an angle, so it's going to be side, angle, side. So that's the first thing that we're then going to do. And then now, after that, we are going to say, look, isn't it that from our construction, this angle is going to be close to this angle because of congruence, and similarly also this angle is going to be close to this angle, right? So look, we are going to say your GMN MN is going to be close to our angle K, and similarly also our what? Our G N M, this angle is going to be close to our angle L, and this is because of what? This is because of congruent triangles. Remember, congruent triangles actually tells us that all these triangles are going to be equal in size and also in length, right? So therefore we can conclude based on those fundamentals. And then now similarly we say, okay, this side now is equals to this side, and also this side is equals to this side. But what did we already know? We already knew that actually our angle H, or our angle H here, our angle H was equals to our angle K, which was our given, and also our angle what? Our angle, what is this? Our angle L, or our angle I, was equals to our angle L. This was given to us, isn't it so? This statement were given to us. So therefore we can actually now provide a conclusion that actually, can you see that this MN is going to be parallel to this, because these two angles now are corresponding, which means actually we can abbreviate this as Z similarly to this one, because this angle is equals to this angle and this angle is equals to this angle, right? So we can then come to our conclusion and say, look, we are going to say now our MN, let me make up my space here, hopefully it's visible. Our MN is going to be parallel to what? Our MN is going to be parallel to our HI. What is now going to be the reason behind those parallel? It's because of we are having corresponding angles. Remember, this angle was equal to this angle. These angles are corresponding, so we can then conclude on what? On this side being parallel, right? So therefore, if these two sides now, if we've concluded that these two sides are parallel, then now we can now conclude on proportionality, right? We can conclude that, remember, from this theorem, if they say if the corresponding angles of the two triangles are equal, then the corresponding sides are in proportion. And we have proven that indeed these two corresponding angles are what? These two angles are corresponding. Therefore, you can prove actually that these two sides are in proportion. So now you can come and conclude and say, so therefore, GH. So you can come and say, therefore, actually, GH over what? GH over GM is going to be equals to what? GH over GM is going to be equals to your GI over your what? Over your GN. This is going to be simply because of what? Because of proportionality theorem. Because of proportionality theorem, Why proportionality theorem? Because we know that now our MN is actually parallel to our HI. That's why we are concluding on that. Now, which means therefore you can also conclude that, remember that you have proven that your GM, this GM was equals to your JK, and also this GN was equals to your JL. So which means in a space for GM, you can conclude that your GH over what? Over JK. Remember, JK and JM are the same thing, so these two things are equal. Same as what? GI, or are in proportion of GI and also what? Your JL. Right? That's the first thing that you can conclude on. And then now you can say similarly. Similarly now, if you have proven that, so you can say similarly or similarly. You can then conclude that actually your JH over what? Your JH over JK is in proportion with your HI over your JL. Your HI over your JL, which means it's still in proportion. These two sides are still in proportion. Remember, your GH over your what? Your JK, because these two sides were equal, are in proportion with what? With this side, which is the longer side, over the smaller side. And this is still because of prop theorem. And why prop theorem? Because of construction. Remember, we've constructed, so this is also because of our construction. So therefore now what else then you can conclude? You can actually now conclude that, now look, firstly your GH, let me write it here. So you can conclude that actually your GH over your JK is going to be equals to what? Is going to be equals to your GI over your what? Your JL, which is going to be equals to what? Which is going to be equals to your HI over your JL. And then you have proven what you are required to prove.